We're doing 3.3. And it says, what are the real solutions to this? Well, one thing you could do is factor, or you could use the quadratic formula. Let's see if we can factor this. Be 2x and x. And we have to get 7. And we have to be subtracting because one's going to be plus and one's going to be minus. So 2 times 4 would be 8. 1 times x, 1 and 4 make 4. And we want plus 7, so we better make it a plus 8 and a minus 1x. So if I set that equal to 0, I add 1, divide by 2, and I get x equals 1/2. Set that equal to 0, and I get x equals -4. And so the real solutions are 1/2 and -4. (32) Graph using transformations. Well, this doesn't tell us the transformations. We need to complete the square. So it's got this ugly number, but we need to make it 1 in front of the x squared. So we need to factor out the 2/3 from the first two. Remember, we just leave the -1 hanging. So 2/3 times what makes x squared? 2/3 x squared be x squared. 2/3 times what would make 4/3 x, and that would be 2x. 2 times 2/3 is 4/3. And then we have to add something and subtract something. Half of 2 is 1. 1 squared is 1, and -1. So then, to finish up here, these three factored are x plus 1 squared, x plus 1 times x plus 1. That's times 2/3, as is the -1 times 2/3, which is -2/3, and then -1. So we have 2/3 x plus 1 squared minus 3/3, and 2/3 is -5/3. So the transformations, I'd go from the regular parabola, 1, 1, -1, 1, 2, 4, -2, 4, to move it -1, and then on the outside, I do the multiplication before the subtraction, so I'd take 2/3 of the height. So now I'm going to be a little bit more careful on this. At 2/3 of the height, 2/3 of the distance from there. So the -1, 0 stays -1, 0. The 0, 1 on a standard parabola, 1 over is up 1, is going to go to 2/3 of 1, which is 2/3. And if I go back 1 from there at -2, it's going to go up not 1 but 2/3 of 1, which is there. And if I go over 2, I would normally go up 4, and 2/3 of 4 is 8/3, or 1 and 8/3 is 1 and 2/3, which is right about there, and over above -3, and that's the trickier one to do. And then I got to take this whole curve, each point that I just figured out, and drop it 1 and 2/3. So this would be vertical compression by 2/3, and then I have to drop it down 5/3, and I'll let you do that last graph. Okay, 52 says write equation for this. Well, y equals, I'm going to do this since I know the vertex, I'm going to use the standard form, which is ax plus b squared plus c, and so it is minus 2 for the b, x minus 2 would move it over 2. The 3 for the c, because it's up 3. It's on the outside same, inside opposite. And then the a. Now I could just put a and solve by putting this point in. But I can also, if I put in, well, let's do that. If I put in 0, and I need to find the a, I'm supposed to get minus 1. 0 minus 2 squared plus 3, so I'm going to subtract 3. And that's going to equal minus 2 squared is 4a, so a is going to be minus 1. So my final equation, I'm going to put a minus 1 there, and so I'm going to get y equals negative 1 x minus 2 squared plus 3. 56 says, is this got a max or min? Well, since it's a negative on the x squared, it's upside down, so it's going to have a max. And what is that value? Well, it's going to happen at the vertex, which is at negative b over 2a. Negative b is going to be negative 12, the opposite of b, over 2 times negative 2 is negative 4, so that's happening at 3. The value will be what I get when I put 3 in here. So it's going to be minus 2 times 3 squared plus 12 times 3. So that's 9 times negative 2 is negative 18 plus 36, which is 18. That's the maximum value. This one is also upside down, so it's going to have a max in the opposite of b over 2 times a happens at 2. Negative 8 divided by negative 4 is 2. So the value is going to be negative 2 times 2 squared plus 8 times 2 plus 3 for negative 8 plus 16 plus 3, and that is 8 plus 3 is 11. $72. If the vertex is here, this doesn't help us very much, but the other form does. F of x is a x minus 1, since it's moved plus 1, and it's moved up 4 plus 4. And if I put in negative 1 for the x, I'm supposed to get negative 8 for the y. Negative 1 minus 1 squared plus 4. Subtract 4 from both sides. Negative 2 squared, which is 4, so I divide both sides by 4 and I get negative 3 is a. So now I have f of x equals negative 3 parenthesis x minus 1 squared, going right off of this, plus 4. And now if I FOIL out the x minus 1 times x minus 1 x squared minus x minus 2x plus 1 times a negative 3, so I'm going to get negative 3x squared. Negative 3 times negative 2 is plus 6x. Negative 3 times 1 is negative 3 plus the 4. I get, in this form, negative 3x squared plus 6x plus 1. There are other ways to doing it, but that's good enough for me. Okay. When are they equal? Well, that would be when, we're supposed to graph this. So, plus 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's an upside down. If I move 1 over, I go down 1, 1 over, down 1, and it's a 1, so it's not stretched or anything. Move over 2, and it's down 4. 1, 2, 3, 4, and 4. And if I go over 3, it's going to be down 3 squared, which is 9. And so it looks like that. 2x plus 1, so through 1, up 2 over 1, up 2 over 1, so it hits that point, which was 1, 2, and 1, 2, 3, 4, 5. Okay, and then if I go the other direction, well, my pen's coming apart here. If I go the other direction, I go down 2, back 1, down 2 more, back 1, 1, and then down 2 more, back 1. It looks like that might be it, so that's minus 3, and down 1, 3, 5, maybe 5, approximately, I can't see here, but that's roughly what's going on. Let's solve. So negative x squared plus 9 equals 2x plus 1. That's what they ask us to do. So I'm going to move the x squared over and the 9 over by adding x squared to both sides. And I've got a plus 2x over there already. I'm going to go minus 9 and minus 9, so that's going to be minus 8. I'm going to factor, or use the quadratic formula. I'm going to factor x plus 4 and x minus 2, because that'll make minus 8. And minus 2 and plus 4, minus plus 4 and minus 2 is plus 2, and the x squared. So I know it happens at negative 4, so not negative 3, negative 4, which should take us down, since that's going down 2, be negative 7. Oh, that was negative 5. Negative 7 looks like the intersection point. Let's see here. And the other one is at plus 2, because 2 would make that 0 and negative 4 would make that 0. So those look like the intersection points. X equals negative 4 or 2. Label the intersections. Got them. So when is f, the parabola, greater than g, the line? Well, it happens between negative 4 and 2 that the parabola is above the g. So that happens between negative 4 and 2. X of negative 4 to the x of 2. 80 has x-intercepts of that, so write an equation. Well, that could be f of x equals, well, it has to have an x plus 5 as a factor, and it has to have an x minus 3 as a factor. And if I multiply that out, I'd get, there could be a number here, and they're saying make it be 1. So then in that case, it would be x squared plus minus 3x plus 5x is plus 2x minus 15. If it was going to stay through those same zeros and have minus 2 as an a, I'd have to put a minus 2 here, and it would be minus 2 times whatever that is. So it'd be f of x would be minus 2x squared minus 4x plus 30. If I want 5, I'd have to take 5 times this stuff, and so I'd have f of x equals 5x squared plus 10x minus 75. If I do it this way, where I'm just changing this number and keeping the factors the same, it has no effect on the intercepts. And that's what it said. Keep these as the x-intercepts. No effect. What's to do to the axis of symmetry? Nothing, because the minus b over 2a will be the same ratio, because each time I just multiplied by a different number, but the ratio would be the same. So none. No effect. What's it affect? How does it affect the vertex? Well, the x-coordinate's always going to be the same because of the same axis of symmetry. The vertex gets moved up or down. Moved up or down, but same x coordinate. And is the vertex, what's the relationship between the vertex and the intercepts? Well, the axis of symmetry is always going to be right between, since it's symmetry, between the intercepts. So the vertex, x coordinate of the vertex, I'll write it over here, the x of vertex is in the middle of the x-intercepts, and I can find it by just taking the average of them. So minus 5 plus 3 divided by 2 is going to be negative 2 divided by 2, negative 1. The x-coordinate of the vertex is negative 1. It's right in the middle of them. And that's it.